In this video, I will demonstrate how to sketch exponential graphs. Now, we will be able to find the x-intercepts using by solving for the x-intercept using logarithms. So what we're going to do first, just before we sketch up the graph, is analyze here our base graph. Now, our base graph here is 2 to the power of x. So let's draw out what this looks like from a rough perspective. If we just draw out y equals 2 to the power of x, we'll have a horizontal asymptote at y equals 0, and our graph will slowly increase as we go across. The other thing as well is if we want to find the y-intercept here, we let x equals 0, and so 2 to the power of 0 is equal to 1. So when x is equal to 0, y is equal to 1. Now, the next thing we ask ourselves here is if we want to sketch f of x, we ask what happens to the graph on top. And essentially what happens on top of this graph is we translate 3 units down because it's -3, it's a constant. So essentially the entire blue graph here shifts down by 3 units. So this horizontal asymptote of y equals 0 moves down by 3 units. So we will start our asymptote at y equals -3. We could also just make it simple, nice and easy for us, and just move this down. And our y-intercept will now be at, by 3 units, 1 minus 3 is -2. So 0 and -2. The shape of the graph is retained. So if we just do a little mini sketch, you can see that it should cross through. Sorry, that was a really poor sketch. It should pass through this y-intercept. However, we also have a query here of what this value is. So we're going to find out what our x-intercept is. So to find out our x-intercept, we're going to let y equals 0. Now, always write this title if you can. And since we are using f of x notation, we're letting f of x equal to 0. So I've got 2 to the power of x minus 3 equals 0, 2 to the power of x equals 3, and the opposite of a base of 2, that is an exponential, if we shift it across to the other side, it becomes a log base 2. And that 3 becomes encapsulated within the bracket. Now, where does this exist? Well, essentially we can ask ourselves, 2 to the power of what equals to 3? Well, 2 to the power of 2 to the power of 1 is equal to 2, whereas 2 to the power of 2 is equal to 4. So this box here must be a number between 1 to 2. So let's just make an assumption that it's somewhere between 1 to 2 here. We're going to cross somewhere along that line. We don't need to make it perfect, we just need to make it cross somewhere along the line there. However, we can actually find out another perfect value here. If we let x equals 1, and if we let x equals 2, then essentially that might give us a better idea, because if we find out where x is equal to 1, x equals to 2, we can connect the dots that the line will have to cross somewhere in between. So if you want to do this as an extra step, by all means. However, this graph here was sufficient, and all you would have to do is just substitute in the value of log base 2 of 3 and 0. And that's it. We've got our asymptote equation, we've got our y-intercept, and we've also got our x-intercept. Now, just for fun, if we wanted to, let's go ahead and find these extra points. Let's find out when x is equal to, I'm just going to do the calculation over here in green, when x is equal to 1 and when x is equal to 2. In other words, for our f of x function, we can find f of 1 and f of 2. Minus 1. At 1, we end up at minus 1. And we also end up here. So now when we go to sketch our graph, we need to make sure we pass through each of these target values. We don't need to label those two dots if you don't want to, because you only need to label in 2. And the x-intercept and the y-intercept will take priority. Don't forget to pause. Oh, just before we pause, we need to find our domain and range. So for our domain, we can see this graph keeps going further to the left, which indicates to us that we start from negative infinity and we keep going further to the right here as we go up, so to positive infinity, which is the same as all real numbers. Our range starts from our lowest value, which is a y value of -3. And as we continue to scan the graph, this continues to go up and up and up, which means that it goes to positive infinity. There we go. So I'll pause the video here before we move on to the next one. So don't forget to pause, rewind, replay if you want to rewatch.